Another way that we might come across these trig equations that need to be solved, whether you want to or not, you're going to learn it, we're going to learn it, is something like this where we have two different trig functions in one equation. Here we have sine of x times tan of x is equal to sine of x. So we have sine and tangent. And the approach we're going to take with these is we are always going to try to factor them so that we are able to separate the two different trig functions in two different factors, which will then give us two different equations that we'll be able to solve. So before we jump into that, let's take a look. We're going to be looking at all answers in this period between 0 and 2 pi. And we know that that's the normal period for our sine. For tangent, it's our normal period is just pi. But this is the 0 to 360 where we're going to be looking for our answers. The other thing to take a look at is, thank goodness, that we're looking at sine x tan x. So the b in both of these is 1, which means we're not messing with our period at all. So we can just look for the answers that we would anticipate between 0 and 2 pi or 0 and 360 degrees. To get started with this in regards to the algebra, we know that whenever we want to solve an equation using factoring, we absolutely have to have a 0 on one side of the equation, which we are not seeing. We have sine times tan on this side and sine on this side. So the first thing we have to do is algebraically get the 0 on this side, and we're going to do that by subtracting sine from both sides. So when we do that, we have our sine x tan x, and now we have minus sine x, and this is equal to 0. This is all we can do here. We're subtracting sine x, but we cannot, under any circumstances, subtract this sine x from this sine x here, because this sine x is linked to that tan x through multiplication. So we subtract it, and on this side, it just sits there, that subtraction. Now we are going to look at this to see, can we factor this? And we see that we can, because we have a sine x here and a sine x here. So that sine of x would be our greatest common factor, and we will factor it out. So sine x goes on the outside of the parentheses, and now when we divide sine x out of this term, sine x tan x, we are left with tan x, and when we divide negative sine x by sine x, we are left with a negative 1, and this is equal to 0. So this is factoring out a greatest common factor like you've done with algebra. Now it's just involving trig statements in there. Each factor gives us a little mini equation, because this times this is 0. That says this could be 0 or this could be 0. We don't know which, so we set each factor equal to 0. So we get sine of x is equal to 0, and then we have the equation tan of x minus 1 is equal to 0. I'm going to solve this here, add 1 to both sides, and get tan of x is equal to 1. So now we have two statements. The sine of x is equal to 0, and the tan of x, another trig function, is equal to 1. So we have to consider our solutions here. What angle has a sine of 0? Well, we know when x is 0, we get a sine of 0, and when x is pi, we get a sine of 0. So here's an example where our answers are one of the quadrantal angles, and we do get two solutions. In another example, we only got one because there was only one value where sine of x was 1, and that was pi over 2. But in terms of when sine of x is equal to 0, that happens at 0 and also pi or 180. So we have two solutions for the sine piece. Now looking at the tangent piece of this equation. We're looking at the tangent of x is equal to 1. Well, we know that x is could be pi over 4 because the angle that has a tangent of 1 would be pi over 4. And this is going to be from Q1. Normally, with tangent, we only would look in Q1, and then we would do the plus pi n thing to crank out the rest of the potential solutions. What I'm going to suggest here is, because we are looking just between 0 and 2 pi, we're looking in our Q1, Q2, Q3, Q4. We know that tangent is positive. Don't forget this is positive in Q1, and we know that tangent is also positive in Q3. So I'm going to skip the process of adding pi over n and finding the solutions that way, and just go right to Q3 to find my other angle. And in Q3, x would be 5 pi over 4. So here we have 4 answers, 2 that we got from the sine function and 2 that we got from the tangent function.